Hey guys, this is Lainey here to walk you through my design process for the Courtland Street Bridge Construction Challenge. To provide a little bit of background information, the construction crew ran into a few issues when it came time to demo the existing Pier number 5. The beams for span 3 are supposed to arrive in 5 days, but the pier needs to be demoed prior to the erection of these beams, otherwise the new beams will clash with the existing pier. The original demo plan would have taken 3 days, but MARTA will only allow for 1 day before the beams arrive. The idea here is to create a new demo plan that will remove enough of Pier number 5 to allow for the erection of the beam in span 3, but to demo a small enough piece so that it will only require 1 day to demo. With challenges like these, you run into a multitude of constraints. The site itself has a huge constraint with the railroad running right next to the existing pier. The demo plan is constrained by the crane size, counterweight used, boom lift radius, and the maximum capacity of the boom lift at full boom length. Other things to consider include the material availability, the cost and labor required to achieve this in 1 day, and the effect this will have on the environment and community. With all of this in mind, it was determined that the MLC 300 crane with 474,400 pounds of counterweight was to be utilized since this was already on site for the other demolition plan. The crane has 177 feet of boom length. Due to all of the surrounding buildings and roadways, the closest the crane can get to the pier is approximately 71 feet. This allows the community to be out of harm's way while also allowing ample distance to demo the pier. Looking at a typical load chart for this particular crane size and boom length, the maximum load capacity would be 150,700 pounds. A 50% factor of safety is required for all of the crane loads, which would bring our maximum capacity to 100,467 pounds. In order to demo this in 1 day, the goal is to demo a piece that is under the maximum capacity, but still allows plenty of space for the beams. My thought process was that any concrete directly underneath the beams needed to be demolished. If any of this concrete were to stay, it would cause difficulties trying to get the lift points connected after the beams are installed. On each side of the beams, I knew I needed a bit of clearance to allow the beams to be set without hitting the columns of the pier. I provided 3 inches of clearance on either side. Using this thought process and an assumed concrete weight of 150 pounds per cubic foot, the total weight of the demo piece would be approximately 85,950 pounds, which is well under the maximum capacity of the crane. If the beam erection crew requires a larger clearance than 3 inches, there is a little bit of leeway with the weight to allow for a slightly larger piece. After determining that this piece is small enough for the crane to handle, I had to determine its center of gravity in order to determine where the pick point should be. I broke up the piece into 6 different rectangles, found the center of gravity for each of these pieces, and then combined them all to determine the total center of gravity for the piece. By combining the centers of gravity, I determined that the total center of gravity is 13 feet from the left side and 2 feet 9 inches from the bottom of the section. To find the pick points, I ensured that each point would carry an approximately equal load. Positioning the pick points 8 feet from either side of the center of gravity provides a stable lifting path, as the load will be evenly distributed between both picks. This completes my solution to the construction issue for the Courtland Street Bridge project. Thanks for watching.